Hello everyone. My name is Daria. I work at Noveltis, and today I'm here to do a short presentation on how to use WEkEO service products in QGIS, and we will focus specifically on a study of 2022 Pakistani floods. I have very not much time, so I'm not gonna be very precise. If you want to see more in-depth instruction how to do this, how to follow this tutorial, you can find the video on a Padlet, and also later you will have access to a PDF version of this tutorial, which is even more um, more precise. We're going to study Pakistani floods, which happened, as you may know, in at the summer of 2022, which caused a lot of damage, and of course, a lot of people were killed, and yeah. So we're going straight to QGIS. So here, what I want to say very briefly that I already did this project, so I already did all the exercises. So I'm going to just shortly show you the results of several functions and features of QGIS. And again, you will follow it if you want. You can follow it with a video or PDF tutorial. So I'm not gonna stop on how to download data because you've been already instructed how to do that. Here we use two types of data. First is a river discharge. So it's gonna be we're gonna import it as a raster data, and also what we're gonna work with satellite images as also as raster data. So we have two exercises, and first is gonna be exactly about the river discharge. So river discharge is basically the amount of water which passes through the river per specific unit of time. So that's been done. Is the river discharge has been mapped, and the style has been adjusted. So here, for example, you can see that blue corresponds to 0 river discharge because there are no rivers, and you can clearly see the footprints of rivers. So here, this one corresponds to the 30th of August 2022. We have time frames from 1st of June of 2022 till 10th of September. And on this exact time frame, we chose for further analysis just because it was having quite extreme values of river discharge. You of course can play with any other date or maybe with all of them if you want and you have time. So here you can see the scale, and you can see that this river here in very red has a very big, very high values of river discharge. This is the Indus River, which been impacted the most by the Pakistani floods. So if you Google the Indus River, what's the average normal river discharge? It's around 5,000 cubic meters per second, if I'm not mistaken. So here you can see that the max value here is 6,000, so it's bigger than the average discharge. But this actually is this value is normalized for all the layers here. Like for example, I can put here, like in the beginning of summer, it was not that bad, or like you can see. But if we right click and go to properties, we will see that actually, let me go to, yes, if you go to max value here in bands, you can actually see that the max value is 25,000, almost 26,000. So you can imagine how much bigger, sorry, river discharge was than the average one. So that's what was the reason to choose explicitly this time frame. So here, what we can see is a lot of rivers, so big area, covers several countries, not only Pakistan. So next step, what we did, we wanted to have only the data only on the Pakistan itself. So for this this layer, you might, I hope you see because it's a bit specific with blue lines. This is layer with country borders for the whole world. It's external layer. You can export it. It's all given in a PDF file, and we transform it to polygons. So now we have basically polygons representing each country. And to do this, you can go to polygonize in vector, if I'm not mistaken. Yeah, here in vector geometry polygonize, you can create from lines polygons. And then from all these countries, only all the polygons, only one polygon has been chosen. So the Pakistan one, I can tag it, and it's been clipped. So this raster layer, the one behind you see for the 30th of August, it's been clipped according to this polygon. So as a result, we have this. So basically now we have our river discharge, which are interested in explicitly in Pakistan. So we don't see the rivers that are not belonging to it, for example. And to do this, to clip the raster layer with some mask, you go to raster, you go to extraction, clip raster by mask layer. Here you put your raster layer, you put your mask, and yeah, you choose maybe if you want to, well, yeah, some optional features, you run and close. So for this exercise, what we want to do is to find out how far away the major cities of Pakistan are from this river, from the Indus River. So we found this um, open source database with the major cities of Pakistan. So it's only, if I'm not mistaken, it's 150 or something like this of cities. And here you can see, I think, yeah, there's information about the name, the latitude, longitude, and the population. So you see these circles and these marks, they represent population of cities. So the darker circle represents more dense in terms of population city. So here you can see that some cities are very close to rivers, well, most of them next to rivers. So this, so as we want to know, we want to distance to this overflooded river, the Indus River. Of course, this information is not going to be explicitly precise because we see that our resolution is, you can see that the pixels are not very coarse, so it's a bit not very fine mesh, let's say. So it's going to be not so, maybe not very representative if you really want how to say, like in terms of Dade River really like went out of banks and went to the cities, for example. So, but we just here to show you how to use the data we have in QGIS and how to use several QGIS features functions. So to find the distance between this river and the cities we first need to vectorize our layer because it's raster layer, so it's pixels, as I said. And for this, we have this, and it might be not very, let me, okay. So first thing that we did, we vectorized this layer, this raster layer, by basically going to raster, conversion, polygonize, raster to vector. So you choose your raster layer, and it converts it to vector layer. So basically, each pixel becomes a polygon. So like this, we have this. You can see a lot of polygons. And what I did after, I go right-click, filter, and I put this expression. So this expression is exactly like this value is the normal average um, river discharge of this river, of the Indus River. So we do the, if we want to find the discharge river which is bigger to show the, yeah, okay, so here it shows us that during this date it was exactly this, these little pixels. And next, we want to find the distance, but before, after we polygonize and we convert from raster layer to vector layer, we have a lot of features, a lot of polygons which are not valid. So there's some error which happen to one or more or several polygons, and you won't visually see it like yourself, but when you will continue doing some special analysis, you will use some features and functions of QGIS, you will see that QGIS will tell you, um, I cannot work with that because you have some errors. Please fix it before proceeding. So to do this, we fix our geometry. As I said, like this is a fixed geometry which has no like visual difference for us. And to do so, we basically go to fixed geometry. There is one function here which you use, which you put your polygon, which you want to, your polygon layer, which you want to fix, and you run, and you have this. So next, what we want to do is to find the distances. So now we see that basically these little polygons, so we can find, so now it's not a pixel, it's a polygon, so we can find the distance between these little polygons and the closest to them cities. For this, we go to nearest hub. Okay, so in vector analysis tab, there's a distance to nearest hub, line hub, which we're gonna use, and use a source layer and destination layer. Yeah, like important notice why we converted our raster layer to vector layer is because this function works only with vector layers. So you can see here, you can see that it's polygons, it's lines, it's points, but yeah, no raster layers, sorry. So after this function is done, you will see something like this. So this is basically, these lines, they represent the distance. Yeah, they represent basically the line, the closest path from this specific city to the closest to them polygon representing the river, part of the river which is overflooded at this point, at this moment. And if we go to right click, open attribute table, we will see here the last column, how distance. This is our distance in kilometers. So if you want to play more with it, you can put some filters for, I don't know, less than 1 kilometer close to river and so on. So that was it for the first exercise. I'll show it. Yeah, I know it's very fast and maybe it's not very clear, but yeah, we have a tight timing. So, okay, so for second exercise, we're gonna work with satellite images. And for this first, I'm gonna, like here we have a background layer and QGIS doesn't have a, how to say, default background layer. You add it yourself. So we usually add this one because this is pretty much enough. But if you go very like zoom in, you see that the image is not very fine. So what I did, I imported another layer, raster layer, and our background layer, which is basically our um Google Maps, basically. So you can really go quite like zoom in quite close and see quite good resolution of a picture. And we need is just to see basically river and how it changes. So here you can see that this is exactly the river we are interested in, the Indus River here. And what we're going to do, we're going to use images, satellite images, which are going to be exported as imported as raster layers. So for this, we chose 2 different days. So one was in, if I'm not mistaken, was 27th of February in 2022. So before the floods, way before the floods. And the second was after, during, let's say, floods. It's 30th of September. And so for example, I show you the image. Let me see. Okay, it's here. So of course, it's a small satellite image, just one specific area where we can see the river. Here you can see it. By untagging and tagging, you might even see the difference between what you can see from Google Maps. I don't know exactly the date of this map has been um, created from pictures taken, but we can see that the river changed. And also, I'll show you this. So it's after or like during, and this is okay. It takes a bit time. This is before. So this is the usual the true color pictures. We also will need these images, these two bands. So it's a band 3 and band 8 of a Sentinel-2 Sentinel-2 satellite. And we need these two specific bands to calculate our normalized difference water index. So this is an index which allows us to spot water bodies on satellite images. If you want to read more about this, there's some info given in a PDF file, and there's also internet. You can go and explore more. So yes, we have also these two bands, which all these pictures were imported very easily by layer, add raster layer, and you just navigate towards the directory where you have the images. And yes. So the next step was to calculate exactly this NDWE, so water index. And that's the resulting one. So this is how it looks like, the resulting index. And to calculate it, you will need to use a raster calculator here. And in raster calculator, you basically put the formula with your raster layers to have it. And I don't remember exactly the formula right now, but I think it's band 3 minus band 8 divided by the sum of band 3 and band 8. Maybe the order is switched. Cannot say right now. But it's of course given in more precise in a PDF version. So after this formula is used in calculation, we will see this for this picture for the 27th of February, so before floods. And this is after, let me just show you how it looks like, yeah. And next, what we need to do is to create a water mask. So exactly the, like to extract pixels which are representing only water, nothing else. And for this, we also use raster calculator, and this I remember for sure. This one, you put this water index which is equal to 1. So pixels that are representing water, they are having value 1, and pixels which are representing something else is 0. So like this, we have two results. So this is our water masks for 30th of September. So you can see there's only black and white. So white's water, black is everything else. And I have the same for February. Yes. So for example, even now you can see that in February, it was like, let's say, less water pixels was detected than for 30th of September. You can see the difference. And the last step is, what if we want to have these pixels, these like water bodies, but like polygons. So we can again easily do it by the thing that I already showed you. So it's vectorized. So it's from raster conversion, raster to vector, and you choose the water mask as an input layer because it's a raster layer. We know it's pixels, and at the end we will have. Let me untag everything. We will have this, and of course it's already filtered, as I already showed you. This is the filter. So I showed only the polygon corresponding to river, because if I yes, so after you vectorize, you have this full full area, full area being vectorized. So all pixels with value 0 and 1 was vectorized, and when you put the condition, you can have only a specific subset. Maybe it takes some time, or I don't know what happened. Okay, let's filter it again. Okay, yeah, now it worked. So now you can see the rivers, and here you can like check it how it corresponds to the background layer. And also, if you see what was before, okay, QGIS is a bit tired. I think it's a bit slow. Let's give it some time. Okay. Yeah, okay. So yeah, here you can see the difference between red is red. Yeah, okay. Red is our how river looked during before flooding, and in orange how it looked during / after flooding. So yeah, here you can see the difference. You can perform more calculations and more analysis if you wish to. And you might see that, especially like here, we won't compare, but for example, if we leave our February polygon and turn, where is it, represent also a picture. Yeah, you can see, for example, if we untick our vector, we see that, yeah, this is water, right? This like greenish colored one. But we also consider that this stuff might be considered as river, right? It's probably some sand or like something that's maybe at this exact date. So it was at 27th of February, wasn't covered with water, but like in 2 days it's going to be covered with water. But of course, for the image, satellite image, after we calculate with water index, it already is not considering it as a river, so it shows like less. And sometimes, yes, you can see maybe that it doesn't consider all water pixels, so it's yeah, like this water index, how to say, might be more precise. So that's a standardized index, but we can see that sometimes it might not work perfectly. So that was mostly it. That was very, very quick. I hope it wasn't too hectic. So yes, I just showed you how to briefly how to use some raster data from WEkEO service, satellite images, and just some data about, for example, we use this river discharge, how to map it, how to vectorize it, how to do some calculations. And yes, you are free to reuse this example for something else, or even push forward, repeat this example, and maybe calculate even more exactly for this application.
Thank you, Daria. It was indeed very quick, but I hope this was just enough teasing for people to play around with the data. And now we have a few questions for you. Let's see. Can you indicate the raster source of the river dischargers?
Yes, this is okay. I don't share a screen, right? Okay, well,
You can if you want.
yeah, it's just no. I need to find it. I think it's if you go to WEkEO platform and you just go to add new layer and put river discharge. I think it's gonna be basically like the first one or something. Um,
on
Never
the
mind.
filter.
Yeah. So, but there's also like the precise link for it is gonna be in PDF file. All the
Yes.
links are given, and also all the data, like not only the links, but also like which area has been downloaded, which time frames, and so on.
Yes. Great. Another one. You're placing Sentinel data over Google Map. What is your comment on image distortion, such as mismatch in locations, because they are different satellites data. Is that right?
Um, I'm not getting. Okay, so yeah, I changed the background because there's in our tutorials we usually use one specific background, which is has not very fine. It's not very fine resolution actually. Like you don't see the river basically if you want to see it. And for this tutorial, I just used another background like Google Maps. You can use whatever you want, and it was mostly also to show that there is a number of possibilities of a background, and it was just to see basically like more features and
Okay.
mismatching locations. I don't know. I didn't check this point, but I think they were quite on point together.
Okay. Thank you. And now we have, well, so it's a comment and several questions in once. So I'm beginning GIS and QGIS. What is the significance of vectorization? So it is kind of a broad question. I don't know if.
Yeah, I'm reading.
So when we do analysis over
Mhm.
river, what is the meaning of vectorization?
So basically, in QGIS, you have to let's very like strictly separate layers. There are two different types of layers. There are raster layers and vector layers. And based on that, QGIS have different features, different functions, different options you can work with, specifically for raster layers and for vector layers. And there are many functions which are like they're intertwined. So basically you can use the same, like you can have the same result from from raster layer with pixels and from vector layer from with polygons. But some features are only available if you work with raster or only with polygons, so with vector. So that's basically the whole point of vectorization, to access other features, uh, other features which are not available for raster layers.
Great. And I think that's all the questions for you, Daria.
Okay.
Thank you very much. And yes,
Mhm.
like Daria said, more information will be on the PDF and on the Padlet. Just to remind you to have access to the Padlet, if you take a look at the top of your screen, you will see a yellow button saying WEkEO workshop material. That's where everything is going to be. So thanks a lot, Daria, and thank you everyone who has presented today. Erkan, David, Julia. I think Julia is no longer here with us, but yes, thank you for your participation. It was very interesting. I found it very interesting. I'm sure our participants as well, by the comments we have seen.